Our next topic would be a discussion about schedule of loads. So disclaimer, I am not a certified electrician, or nor am I a licensed electrical engineer. But somehow I do have some ideas on how these loads are being computed. This will give you an idea on how this should be interpreted if in case when you finish civil engineering and then you start making constructions. This is very essential that we know how to read this, especially for small scale construction such as a residential building. So please do take note of the previous discussion about ground floor, care of convenience outlet layout, and also for the mezzanine. And then also take note of the lighting layout for both ground floor and mezzanine. Okay, so to start with, in the schedule of loads, this is basically how we are able to design. First one, the size of the breaker, and also the size of the home run. So I hope you do remember what a breaker and a home run looks like. So let me show you first what a circuit breaker looks like. So this is an example of a circuit breaker. So each circuit will have its own circuit breaker. Now these will all circuit breakers will be placed inside or arranged inside a panel board such as this one. These are examples of a panel board. So for example, this is a slot for one circuit breaker. So imagine one circuit breaker is placed on each one. So each circuit breaker controls one circuit. So if ever there is for example, this one, if ever this circuit or some specific circuit tends to overload, or probably there's something wrong with the circuit, this will trip off, meaning it will move from on going all the way to the off side. Okay, so this will trip on its own. So again, this is used to turn on and off each circuit. So this is one whole panel board with circuit breakers for each individual circuits. So this is for the computation or the sizing of the circuit breaker. Sizing meaning the load that it can accommodate. So let's say for example, it shows here that this side here says 15, meaning it is a 15 ampere circuit breaker. So as long as the load of one circuit breaker does not go beyond a 15 ampere load, then the circuit breaker will not trip off. Now there are other sizes. Again, this will depend on the calculated amperage for each circuit. So another one that's shown here is 20, and also there's 30. Now these are bigger loads because these belongs to one refrigerator, air conditioning unit, and of course the convenience outlets. Okay, to start with, we'll have to discuss the per row. So for example, in here you have the circuit number, this one. This refers to the circuits that we've previously discussed. For example, this one here, this is C1. No? So all the lights that belong to this circuit will be reflected here. Okay. Next would be for circuit number 2, you'll have to check all the lights belonging, or the fixtures. In this case, it's all lighting because after all, this is the lighting layout. So you'll see here all these lights. So you have to count them manually. Know how many lights belong to this circuit. And it's the same for circuit number 3 as well, wherein it's on the mezzanine part in here. Now you have to count this, how many lights belong to this circuit. So that's C3 and of course C4 as well. Now take note that during your activity last meeting, it was instructed to you that you should be able to provide a legend indicating the wattage of each fixture, especially for the lighting, because it usually has a different wattage. It is a little bit different with that of outlets, because the outlets have more or less a fixed wattage provided, for each outlet. Okay, so that's why again I mentioned you'll just have to count. So in this case, for example, circuit number 1, there are 2 spotlights, so you'll have to write here the 30 watts, and then there are 3 pin lights which are all 10 watts, and then there are 7 30 watts wall lamp, and so forth. No, so after that, you'll just have to multiply 30 times 2, 10 times 3, 30 times 7, and then 30 times 1. So it means after that, you'll just have to add everything. So for 30 times 2, that would be 60. 10 times 3, that would be 30. 30 times 7, that would be 210. And then lastly, 30 times 1, that would be 30 still. So if you sum it all up, that would give you, this is 12, 13, and then 330. It means that circuit number 1 basically has 330 watts. VA means voltage times amperes per circuit. So it means that circuit number 1 has 330 watts worth of lighting. So this column, by the way, indicates if the specific number belongs to lighting, or is it for convenience outlet, or for other loads. So again, you repeat the same process, this time for circuit number 2, multiplying each one. So 30 times 3 times 20, that's 60. 1 times 30 equals 30. 10 times 10, that would be 100. So that would be equal to 190. So again, you'll just have to count them manually, how many that is. So this one is 8 times 10, that would be 80. 2 times 10 of 50, that would be 100. So that if you sum that up, that would be 180. And then lastly, for circuit number 4, just have to multiply 10 by 10. That would mean 100 watts for circuit number 4. Now, usually in the Philippines, especially if we have small refrigerators, we usually have we usually include the refrigerators onto the convenience outlets. But for cases of having the side-by-side refrigerator, two-door side-by-side refrigerator, or probably the four-door side-by-side refrigerator would probably need its own circuit, because it needs more protection than usual, just like what we do with the aircon. So with that, you'll have to add one circuit exclusively for the refrigerator. And here, the wattage is 1500, but of course this will depend, it will vary on the size of the refrigerator, how much power it needs to cool the refrigerator down. So next would be for, again, this should be provided by the seller of the refrigerator. No, same with the air conditioning unit. It's the same with air conditioning unit, wherein you just have to provide as its own circuit, to make sure that you are able to give the proper wattage. Now, the air conditioning unit will depend on the size of the aircon. So what we are familiar with are the horse powers. So sometimes, and also the horsepowers or the sizing of the aircon would depend on the use of the room, the number of occupants, the size of the glass window, if it is with curtain, if it is exposed to the outdoor, or the height of the room, the headroom clearance, etc., the number of occupants. So there are so many things that we need to consider when we do the sizing of the air conditioning unit. With that said, it is the job of supposedly the supplier of the aircon to identify how much horsepower is needed. Now, let's say, for example, you are required to provide for a size of a specific room. Let's say, for example, a bedroom. You are required to provide, let's say, a 2 horsepower air conditioning unit. Now, 2 horsepower would require you to have 1 horsepower would be, if you convert it to watts, would be 746 watts. Now, in here, the watts provided is 1700. So it only means that there's around 2 horsepowers allotted for, more than 2 horsepowers allotted for that specific circuit. So I provided 1700 because, again, it's just a near estimate, just so that there is enough room during the sizing of the aircon, because sometimes the electrical engineer will just have to make an estimate of the size of the aircon that will be provided. As long as anyway, what's important is you are able to provide the right size of the wire and also the right size or capacity of the circuit breaker. Okay, so 1/7. Next would be the convenience outlet. So if you're going to count the convenience outlet here, each circuit has seven outlets. No, this one is, I think, connected to the second floor. But for this one, 2, 3, 4, 5, 6 here, and 7. So the outlets are divided into 7. This is as per request of the electrical engineer who designed it. So it was requested that I only provide 7 outlets for each circuit for purposes of safety. So there are 7 in total. So there are 21 outlets all around the house. And so to make sure that it is evenly placed on each circuit, I just divided it into 3. So there is 7 for each. So each outlet will have roughly 250 watts. It means that each outlet has the capacity to accommodate a 250 watts load. So that's why it is important that you know how much load that you are using for each outlet. That's why it's highly discouraged that you daisy chain or you keep connecting an extension wire onto each outlet, because it makes you unaware of the volume of current that's being withdrawn from that outlet. So again, going back there, since it's 250 watts per outlet, you just basically multiply it to 7, gives you a 1750 watts for each circuit. So since they're all equally distributed or equally placed in a circuit, it means they're all the same. Okay. Next is another air conditioning unit. Now again, like I mentioned, there are so many things you need to consider when it comes to the sizing of the AC. So for this aircon, this basically is more exposed to the heat, or it has more person to accommodate, more people to accommodate, or probably facing the western afternoon sun, should I say. So it means it's going to be more hot in here, in this space. So that's why it needs a bigger capacity. So that's why an estimate of 2,300 watts is being provided. That gives you roughly around a 3 horsepower aircon. Okay. So next would be a spare. So there are 2 spares that are provided. Now the spare is, well, basically for purposes of expansion. Let's say, for example, after the owners have lived in that house for quite a while and noticed that they probably need an additional air conditioning, so the spare circuit will be able to accommodate that. So another example would be if let's say by the end of the year there is a need for them to add an electrical pump for the water supply, and then of course that would need an additional circuit again. So the spare here would be able to accommodate that additional load that is provided beforehand. Okay, so after calculating all the watts per circuit, all you need to do is to divide this by 220, which gives you the amperes. So basically, the purpose of the amperes is for the sizing of both the circuit home run and your circuit breaker. So 330 divided by 220. I hope you do know where we get the 220. 220 is the voltage that we use in the Philippines. For other countries, it's 110. So there's 220. So 330 divided by 220, that's 1.5. 190 divided by 220, that's 0.87. Again, keep going with dividing with 220. You got all of these answers. Okay. So after getting the amperage, that's the time that we do the sizing of the breaker. So the usual size used for lighting circuit breakers are around 15, but then again this will depend on the number of lights or the wattage of the lights being attached to this circuit. In this case, the watts or the amperes required is just 1.5, and still we provided a bigger amperage here, which is 15, which gives you roughly a bigger allowance as to probably if there are changes with the lighting, you still have enough protection for the size of the breaker. Same with the rest of the lighting circuits. So 0.87, this 15 amperes of size of the breaker should be enough. 0.82, again still on the 15, 46, and then 15. Okay, so we cannot use, you might ask, Miss, why not use a bigger amperage for circuit breaker? That's because it could be that the size of the circuit breaker will also have a different price to it. So the higher the capacity, the more expensive the circuit breaker is. Next is this one, wherein it would be the refrigerator. So only a 20 circuit breaker, 20 ampere circuit breaker is being used, because after all it's just a single appliance circuit. No, same with air cons and the air cons. But with the air cons, we are using 30 together with a spare. That's because the air cons and the spare, that is, we probably do not know if the size of it will be, or the load for it will be greater than what we prepared for. So might as well use 30 for safety factor. And then the rest, like the convenience outlet and of course the refrigerator, we only use 20, because basically this does not usually reach the, so let's say for example the plugs for a circuit, or the outlets for a specific circuit, you do not usually use up the 250 for each outlet, because let's say for example you just plug in your cell phone or your electric fan, so you don't necessarily use up everything. So what you need to do is probably choose the 20, since anyway what's needed is just 7.96. It's 20 is still way higher than what it necessarily can take. So that's it. That's the sizing. Next would be the pole. Okay, so this means that it's a 2-pole circuit breaker. A two-pole circuit breaker basically is what we commonly use for residential buildings and small-scale construction, while we have a three-pole for commercial buildings or industrial buildings. So these are basically the 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 big load, kind of industry. Okay. So next would be the time. So the time refers to the amount of time it takes time to trip. So let's say, for example, I think this is in millisecond. Okay. So when there is an overload, it waits for around 20 millisecond. No, that's it's almost a split second. So once it feels as there's an overload, it takes around 20 millisecond before it trips or shuts off. Okay, so it's not long. So automatically it can already detect there's a short circuit. So to protect it to protect the whole circuit from getting burned or getting compromised. So it would only take around 20 millisecond to trip off. Okay, so these are the basic description of each circuit breaker. So this is what you tell the seller what kind of circuit breaker you need to buy. So let's say it should be the size, the poles, and also the time. Okay. So next would be the size of the home run. So basically this is the wire, no, the size of the wire that each circuit will be using. Okay, so again, this will rely on the number of fixtures attached to it, the size or the wattage of the appliances that uses this circuit. No, that's why if you still remember the activity from, I think, the second or two meetings ago, that I required you to draw or to make the sizes of the sizes, and of course the capacity of each wire. So this is where you can use them. No, so this is the area for each circuit. So if you notice, the smaller ones only use the smaller amperage only uses the 3.5 mm squared size. Same as this. While the rest, like the aircon, the refrigerator, and the spare, uses a 5.5 mm squared sizing. While we only use 3.5 mm squared sizes for the convenience outlet, because again, it's not really that much. 3.5 mm squared can be seen, or the capacity that it can carry, the load that it can carry, will be provided or seen in the gauge that I have asked you to draw few meetings back. Okay. Lastly, you have the PVC unit. So what's a PVC? So this is basically the orange hose that protects the wires. So as you can see, they're all 20 mm diameter, because the wires are relatively small. No, so you can fit wires, the 5.5 and the 3.5 onto the 20 mm diameter PVC. So these are the ones that we commonly use, the orange ones that which you see on the walls, planted onto the walls already, or sometimes for big scale construction they usually have the metal ones. Okay, so after that's done, you can now add up all the total amperage for the whole load. Now, why is this necessary? Because by the amperage value here, we can now be able to compute for the main conductor and the main circuit protection. So the main conductor is basically the wire that connects your panel board to VECO, or whoever is your local supplier for your electricity. Okay, so this is the main size of the wire, and also the the main circuit breaker. So I'll show you what the main circuit breaker looks like. So this is an example of a panel board. So again, going back, each circuit will have its own circuit breaker. This one, no. So if you're going to turn this off, if ever there is an overload, this one will trip. Okay, but the main circuit breaker, I think this would be this one, is the one that can shut off everything. Again, the circuit breaker is just for one circuit, while the main circuit breaker is in control of all the circuit breakers. So if there is, let's say, an accident and there's fire, what we usually do is we turn off automatically the main circuit breaker, which is this one. Okay, I will no longer discuss how this is done, because for one, I've noticed that each electrical engineer that I have approached will always have a different way of using the demand factor. Now, if you notice here, it's just 80%. Now, it means that he does not compute for the whole 66.18 amperes of load, because it would be impractical to provide for that amount of load. Because, like I told you a while ago, the higher the load that we compute for, the bigger the capacity of the circuit breaker is needed. And when that happens, the price of the circuit breaker also goes up. So what we do to be practical, we only use an 80% of the demand factor. So the purpose for this is, the reason for this is, it is expected that at a specific at one point you cannot actually turn on all of your outlets or maximize all the loads that you provide for your house. No, so you do not really use up all the outlets or the total of 250 watts per outlet, or turn on all the lights that you have. It doesn't normally happen. So for purposes of probably being practical about it, we use an 80% load instead. No, you're assuming that only 80% of the total load is being used at one point of turning on the electricity. So that's why you only use 80. Okay. Now with the demand factor though, this one, computation itself, sometimes differs for each of the electrical engineer that I have approached. So that's why I will no longer discuss this. So, but in this case, that it has been computed that the amount of amperes that will be used as a reference for sizing the main conductor would be 55, while the wire would be 73. So this is the size of the wire that you're going to use, 22 mm squared. And for the main circuit breaker would be 100 amperes, no, circuit breakers. Okay, so that's it for the circuit load. Now I will move on to the single line diagram. So the single line diagram is basically a diagram of your panel board. So for example, in here you will see a box. So this box represents your panel board, while this one is for circuit 1, this one is for circuit 7, this one circuit 2, circuit 8, and so forth. So this will basically show you the arrangement of your panel board, the sizing of the circuit breaker that you will be needing, no? So if you can picture out the circuit board that I've previously shown you, this is how it looks like. No, there's a circuit breaker again. Same as for the other side, circuit breaker. Okay. And of course, each circuit breaker will have a label to it. So for example, if it's lighting, you write it. So if you try opening your panel boards, you will usually notice that there is for lighting, there's one for probably the aircon, another one for outlets, etc. So we always label, you know, our circuit breakers, so that by the time that there's an emergency, you automatically know which to turn on or off. So for purposes of ease, no, the labeling there is for easy reference. And lastly, in here, this is the size, no, 100 ampere main circuit breaker. So this is again similar to what I've shown you previously. And then this one is of course representing the wire that connects your meter, and then of course to VECO if you are using VECO. So you also have to identify the size of the wire that you need there, because again, this is the wire that connects you to VECO. Now if it's too small, it will most likely have a short circuit, especially if all your electric appliances or whatever are turned on all together. So you might experience probably a short circuit. Now if it's too big, the size of the wire would be too big, it would be also impractical, because again, the size of the wire, the copper of the wire is too expensive. So that's why you need to know when to do the sizing. Again, you refer it to the sizes written from the wire gauge and the capacity of each wire. Okay, so that's it for the single line diagram. Again, basically the single line diagram is just similar to drawing a panel board itself. So lastly, we do the riser diagram. So with the riser diagram, you just lay out all your the location in relation to the height of the building, all of your fixtures. So for example, in here, 5, 9, and 7 are for, I would say, convenience outlets, because convenience outlets are normally located around 0.3 from floor finished floor line. No, it's usually from there. And then sometimes it's also around 1.2 if it's on top of the a counter. No, let's say for example in the kitchen. So, but it's somewhere in the bottom half of each story. Now the Same is for number 8, out for circuit number 8. No, so since it is a convenience outlet, so it's also located at circuit number 8. It's located at the lower half of second floor, or the mezzanine. 6 and 10 on the other hand, represents, or is the outlet for ACU, so it's located on the higher part. No, since we usually locate our aircon on higher elevation. And lastly, you have 1 and 2, and 4 and 3, all are lighting fixtures. So of course it's expected that most of the lighting fixtures are located on the ceiling, so it is on the upper half of each story. Now we did not include 11 and 12, because if you remember, 11 and 12 are spare circuits. No, doesn't necessarily have a location just yet. So again, it's for future expansion, just in case there will be changes necessary. Okay, so again, you don't have to include that here. Okay, so with that, my discussion about schedule of loads, single line diagram, and riser diagram ends this discussion. Thank you.